Now we're going to talk about naming acids. Now we haven't seen acids before, so we'll define them here very simply. It's a little bit more complicated than that, but we'll just say that molecular compounds that produce the H plus ion when they dissolve in water. So they have to be composed of hydrogen, which is written first, and one or more nonmetals, which is written second. So they're sour tasting like the hydrochloric acid in your stomach. They dissolve metals, so they're very strong and corrosive. And usually you'll see the AQ sign, which indicates the compound is aqueous or dissolved in water, because you can never see acid by itself. It's too strong, so it's usually dissolved in water. Now we can have acids that are either binary, so acids start with H. They can either be binary, and they can have two elements only, so H and some other element, or they can be oxyacids. It could be H and usually a polyatomic ion. So let us learn how to name binary acids. So it's a hydrogen and a nonmetal. So the first thing that we want to do is say hydro, the base name of our nonmetal, followed by the ic, and then a space, and we write the word acid. So here, HCl, stomach acid, since it's binary and it starts with an H, so we say hydro, and then we write the base name for our chlorine here, which is chlor, and then instead of writing chlorine, we write chloric. So hydrochloric space acid. Okay, here we have HBr, binary, so we name hydro brom, and then we put the ic ending followed by a space and the word acid. Okay, now you try to name the following. We have a hydrogen first, so it doesn't matter there's two, we just still call it hydro. And then our non-metal is sulfur, so we're going to say sulfur, and then add the ic ending, so hydrosulfuric followed by space and acid. Here we have hydrofluoric acid, the base name followed by the ic, and we have a space and we write the word acid. Okay, now let's learn how to name oxyacids. We've named binary acids in which we have hydrogens and some other nonmetal. Now, if we have the oxyacids, usually it's our polyatomic ions that we've learned, because oxyacids are acids that contain oxyanions, so anything containing oxygen. So here, if we have the name of the acid containing the oxyanion that ends in "ite," we name the base name of the oxyanion, but we change the ending to "us," followed by a space and the word acid. So here we have SO3 -2. We look that up, or we just memorize this, because remember you're supposed to memorize the polyatomic ions. And you know that SO3 -2 is called sulfite. Okay, so what you're going to do, since you have the ite sound, you're going to change it to the us sound. So now you have sulfurous, and then space acid. Okay, here we have, if we want to name acids containing the oxyanion that end in "ate," we change the "ate" to the ic ending. So in this example, we have nitrate. So in nitrate, we have to change the "ate" to the "ic" ending. So it becomes nitric acid. Don't forget to put the space and the name of the acid after that. So just remember that ite goes to us and ate goes to ick. Okay, now go ahead and try this on your own. We learned to recognize that this is an acid because it starts with an H. So when it disassociates or breaks down, it's going to give us the H plus cation, right? And then we learned to recognize this guy here is called acetate. It's our polyatomic ion or oxyanion. And remember, if we have 8, we gotta change it to ick. So we take this out here and we call it acetic acid. Notice we don't have to put hydro or anything in non-binary acids. We only put hydro for binary acids. Here we notice that we have a polyatomic ion again, and this time this is called nitrite. And remember, we want to change the ite into an us sound. So we take the ite out and we call it nitrous. Nitrous acid. Don't forget to say acid. So it's nitrous acid.